Section 2.9, example 48, integrals involving hyperbolic functions. So evaluate the function or the following integrals. Ooh, this sounds like fun. Oh, I was trying to move this out of the way. All right. So before we start anything, let's turn that hyperbolic cosine function into like its equivalents. So we have x e to the x squared plus e to the negative x squared over 2 dx. All right, so that's what it looks like. What I kind of want to do is look at this right here and turn it into something that we're used to. So what I really want to do is let u equal x squared. Du is equal to 2x dx. And let's start throwing everything back in here. Let's factor out that 1 over 2. So we have that. So we factor out this 1 over 2. Du is equal to 2x dx, but all we have is this right here. So let's divide both sides by 2. So that's going to be an extra 1 over 2. And now we have e to the u plus e to the negative u du. All right, let's see what we have. 1 over 4 e to the u minus e to the negative u plus c. We were not in terms of u, we were actually in terms of x, so let's substitute that x back in. 1 over 4 e x squared minus e negative x squared plus c. And I feel like we could grab this 4, or at least a 2 out of the 4, so that way we can make this one hyperbolic sine. So 1 over 2 e to the x squared minus e to the negative x squared over 2 plus c. So I see a 1 over 2 hyperbolic sine function of x squared plus c. That was fun. Okay, now let's, tangent. So we have sines and cosines. Let's move this up just a little bit. Do we have enough room? Oh, we have plenty of room. All right, so here, first, let's turn it into sines and cosines. So hyperbolic sine of x over hyperbolic cosine of x. And now from here, let's look at the actual hyperbolic functions. I'm going to give myself a little bit more room. E to the x minus e to the negative x over 2 over e to the x plus e to the negative x over 2 dx. Doesn't have to be that long. All right, now from here, I kind of want to multiply both top and bottom by 2. So we'll have e to the x minus e to the negative x over e to the x plus e to the negative x. Fun part is if we differentiate this part, we end up with this right here. So what I want to do is let u equal e to the x plus e to the negative x. Du is equal to e to the x minus e to the negative x dx. And that's exactly what we have in the numerator. Look at that. So we're integrating u to the negative 1 du, which is ln of u plus c. We weren't in terms of u, so let's get back in terms of x. e to the x plus e to the negative x plus c. We weren't in terms of e to the x, we were actually in terms of hyperbolic functions. So what I want to do is 1 over, or we could say 2 times that 1 over 2, e to the x plus e to the negative x over 2 plus c, and that right there is cosine. So ln of the absolute value of 2 cosh x plus c. And there we go. Beautiful. Perfect. And that's it. If you have any questions whatsoever, please do not hesitate to ask. Otherwise, bye.